I know it sounds crazy, but I want to make this guitar be able to tune itself. And yes, I do mean motors on the tuning pegs. Hello, my name is Chad, at Metalhead Maker on most socials, except Instagram. On my channel, I've already fully 3D printed a guitar, and yes, that includes the neck, but I want to do something more with it. You see, robots are the second coolest thing in the world next to guitars, so combining the two will result in objectively almost twice as much cool. There's a lot of technology in this video, but in a fun way. You don't have to be an engineer to follow along. This is much more about just making something and having fun with it. On this first phase, there are a few things that I want to make sure that I work into the design. One, it should be able to be controlled by a microcontroller so I can program it. Two, I'm gonna have a whole bunch of electronics squeezed into this little tight space, and I don't want to melt the guitar, nor do I want to burn up any of the electronics, so I need a temperature monitor, a fan, and some sort of ventilation system. Next up, it needs to be able to run off batteries, but it also needs to be able to be charged right in the guitar. I don't want to have to take the battery system out. Sticking with power delivery, I could have gone with a passive pickup and made things easy, but I like EMGs. I'm sorry, I'm lame like that. So I want to be able to run the EMG off of the battery system that I'm using for the rest of the system. I don't want to have a separate 9-volt. Lastly, on the power side of things, I know that I'm going to need to bump around between different voltages for the different types of components, so I need to be able to account for that. Now we're getting to the fun stuff. I want to be able to run RGB LEDs all over the body and the neck of the guitar, maybe even the headstock. And those should be fully programmable so I can do all sorts of sequences and themes. The guitar should have its own manual kill switch, but it should also have a relay override, which will allow me to turn off the guitar signal completely from the microcontroller. I know it sounds crazy, but I want to make this guitar be able to tune itself. And yes, I do mean motors on the tuning pegs. Now I know that a company called Tronical has done this in the past. I think they licensed it to Gibson as well. From what I've seen, when it worked really well, but then it was underdeveloped. I know what I'm getting myself into. I expect a rough road on this part of the project. Moving on. Lastly, and this is a little more like aspiration stuff, I want to take what I've learned from this and apply it to the greater community in some way, shape, or form. I'm not sure what that's actually gonna look like. I just think that it'd be kind of silly for me to take all of this knowledge that I gain over the course of the project and hoard it. So now that we've got our map, let's hit the road. Long before I even started this project, I wanted to build a guitar that had a fretboard that lit up in some way, shape, or form. I found these individually addressable RGB LEDs, say that 5 times fast, that you can chain together to tell each one of those LEDs what to do, whether that be change the color, light up in a sequence, use your imagination. So once I finished building the fretboard, I was able to install all of these pixels, wire them up, and actually just make sure that all of them worked. Oh yeah, I also built in a little spot to light up the fret markers with LEDs. These are little teeny tiny, what's called SMD LEDs, and they're just white. Those little LEDs are supposed to go on a circuit board. That's how they mount. So there's not really a good way to mount them on the side of a fretboard. So basically I just had to kind of wire it all up, do some tests, then pour the resin in and let it cure, hoping that everything still worked afterwards, which it did not. So I had to dig out the resin, fix whatever circuit broke, re-resin it, test again. Eventually I got it to work, and damn, that looks good, but there's no time to revel in victory because I need to move over to the control panel. I overcomplicated this control panel to an embarrassing degree. All it really should have been was a screen, an encoder, and then a few extra buttons for just like quick functions. For some reason, I had it in my head that I wanted to make these buttons dimly lit when the guitar was on, and then as you press the button, it gets a little brighter to give you some kind of indicator or whatever. That's a perfectly fine feature, but this is not what you should be spending your time on in the early stages of prototyping. Apparently, I'm just really bad at following my own advice, but whatever, it's in there. Moving on to power delivery. Now, routing power is a very complex topic. Here's how it was originally gonna work versus how it's actually gonna work now that I understand what I need to do to get that amount of power out of a USB port. I started out by just trying to convert a 5-volt USB-C input to 12 volts using a boost converter, but I'm gonna need a lot more current than that to charge the battery, so I switched over to a USB PD power system. Yeah, I know, this looks stupidly overcomplicated, and you're not wrong. This is your warning. If you don't like super nerdy science stuff, skip ahead about 1 minute. The USB PD system can provide any voltage I need off of that USB-C type port, so I'm taking that and splitting it off into 4 different paths. The first one's really straightforward. It's called a buck converter. It takes the 12 volts and steps it down to 5 volts, so then I can run everything in the guitar without blowing it up. The second one's a little more interesting. I'm using that same 12-volt source to charge the battery pack, which I'm then able to push that same 12 volts from the battery pack to the buck converter and onto the rest of the guitar. I did this so I could run the guitar off the battery pack or the USB input. I think I'm probably going to make some people scratch their heads when they look at that third path that's going directly to the guitar pickup. We all know that active pickups can run off of 9 volts, but did you know that pickups can run off of much higher voltage? In fact, some people run as high as 18 volts. I did a test and it seems to work, so I'm fairly confident that I should be able to run at 12 volts no problem. The bottom path is just for a battery monitor. The microcontroller can only handle up to 3.3 volts, so we have to cut that down from the original 12 volts by using something called a voltage divider. There's one more step in handling the voltage. I have a couple components that require 3.3 volts, so I have to step that down from 5. And that's it. From there, it's just a matter of supplying the right voltage to the right components. Moving on to the main board. This board is what is going to control all of the stuff, all of the electronics, everything on the guitar, including the guitar signal itself. If you've ever seen a motherboard on a computer, you can kind of think of that in the same way as this. Breadboards are notorious for being hard to develop on after you get to a certain point where there's too many wires or it's just too hard to keep track of, and they can come apart really easily. So it's a lot easier to use something like a prototyping board like what you're seeing here to build more permanent circuits. These have their drawbacks though. They can turn into just as much of a mess as a breadboard, and I've tried to combat that as much as possible by using raw copper wire to run traces that are very structured so I can make sense of it as I'm building it out. So yeah, it's a lot of work. The first phase of this is just laying out the critical components to make sure that they fit on the board. In this case, I was trying to make sure that the microcontroller fit and the motor drivers fit, which are basically ICs or the chips that send signals to the motors to run. I also needed to cut down the boards to fit the small space that I had in the guitar cavity. I could have redesigned some stuff and made this bigger, but I don't really want a big hollow guitar. More importantly, I know that if and when I design a PCB or a printed circuit board, I won't need a massive space to fit all this. So once I get everything on the board, that's where it starts to get a little crazy because you've got a bunch of traces running. So one thing I like to do is use Sharpies to mark all of the traces that are based on power. In this case, I'm marking 12 volts as blue, 5 volts as red, and ground as black. After I did enough testing that I was pretty confident that I wasn't going to burn up my microcontroller as soon as I plugged it in, I set up my thermal camera. This isn't necessarily a technique that I learned from anyone, but I do know that anytime I've ever burned up anything, the term burnt up is pretty accurate. You get a lot of heat before you actually get some kind of pop. This also gave me the opportunity to check the microcontroller's base temperature. And once I figured that out, I plugged it in just to make sure that everything was still the same. And I got lucky, I guess. Everything seems to work just fine. So I'm happy because I have burned out one of these before. This is the microcontroller I'm using for the guitar. It is a Teensy 4.1 and they run about $35 to $40 depending on when you buy them and who you buy them from. So at this stage I'm picking up a lot of steam and I decided to move on over to the guitar signal. So I wanted to get the actual guitar's pickup integrated into this circuit. So full humility here, I did not know how to wire a guitar pickup. I've done it probably 4 or 5 times. Didn't know what I was doing when I was doing it. I had to actually learn how all of this stuff worked on a pickup to be able to do this in a way that made sense for the project. Yeah, kind of selective knowledge there. I can't know everything. Oh, and this happened. Mother... Damn it. Aside from that mishap, I was able to get the pickup and the kill switch wired up, and that allowed me to do some preamp testing because we need something like that so we can get the signal high enough for the microcontroller to reach. Finally, after that, we got back to the main board. I wired in the fan, not because I necessarily needed it at this stage, but I wanted to know how much current it was pulling. And then after that, I got to go on to wiring up the motors. This was fun, if not maybe a little bit stressful, because the motors didn't always behave the way I had expected them to. Right now, I'm attributing that to just the chaos of the board. There may be some kind of interference. That is to be determined still. To round it all out, I wrote some quick code to test everything in sequence except the lighting, which I left out because I'm not the brightest bulb. that probably just kind of flew by. But what's happening is that I've got some code that's written to just kind of test every one of the components to make sure that everything's operational. Just doing an overall health check, basically. Obviously, I don't have the lighting tested in there, but I've already tested that, so I'm pretty confident on that. Here's the thing. I'm not gonna finish this prototype. Now, don't get me wrong, I'm super proud of what I built on this so far. It's functional. I mean, as far as I can see, everything works as expected for the most part. There are companies out there that will manufacture a professionally looking printed circuit board for you, and I think that's the route I'm going next. It's a lot of work, but so was this. You know, I've done all of the proof of concept that I can, and it's time to move on to the next phase. I can't even articulate how much I appreciate you spending the time to walk through this project with me. I've gotten an incredibly positive response, and that just gives me just a little hope that I'm not the only one out there that likes stuff like this, and maybe not all guitarists are absolute purists all the time. Hey, I too am a big fan of if it ain't broke, don't fix it, but also there is room for innovation, I think. If you're excited about this project and you want to see it continue, I sound like I'm gonna go hungry. Donate just $20 a day. No, I'm kidding. Just like, subscribe. If you have questions, comments, gripes, anything about this project, please leave them in the comments below. That is what really helps, kind of propel these projects. Thank you so much for watching. Then I will be back soon with another video.